Hi, my name is Taylor and I'm an SI leader at the ARC. And today we're going to be talking about Coulomb's law. So Coulomb's law is a relationship between the force, the electrostatic force between 2 point charges, and the two important factors are going to be charge and distance. So for force, we're going to call it F with a little subscript E for electrostatic force. Charge, we're always going to call it Q. So in this case, we have two charges. So we're going to talk about Q1 and Q2. And distance, we're going to say R, like radius. So for the force on two charges, this is kind of like gravity. So the two charges are both going to have a force on each other. And the magnitude for those two forces are going to be the same, but the opposite direction. So only the sign is switched. So when you calculate Fe, the stronger the charge of your two charges, the greater the force. And so we're going to put our Q1 and Q2 on the top. But there's the opposite relationship with distance. So the greater the distance, the lower the force. So our R is on the bottom, and we're going to square it. So it's proportional to the charges of the two charges, and it is inversely proportional to the square of the distance between them. And then we're going to add on Coulomb's constant, K, which is just equal to 8.99 times 10 to the 9 newtons meters squared over Coulomb squared. And coulombs is going to be our unit of charge. So the type of problems that you're going to see when you're looking at Coulomb's law, your professor is going to give you 2 or 3 point charges, and they're going to ask you to find the force on one of those charges. So for this one, I'm going to label my charges Q1, Q2, and Q3. And for this problem, we're going to look at the charge, or the force on Q3. So we're looking for electrostatic force on Q3. So since you have two charges that the charge 3 is interacting with, we need to look at the force from both of those separately. So I'm going to rewrite Coulomb's law twice. So I'm going to call one F1, and this is going to be the force from charge 1 on charge 3. So I have my K, my two charges in this case are Q1 and Q3. And my R in this case is going to be the distance between Q1 and Q3. So I'm going to say R13 squared. For our second force, it's K. Our two charges are Q2 and Q3. And our distance is between 2 and 3 squared. So it's always helpful when you're first starting out to draw what you expect the forces to be, so we can always check our work at the end. So for this one, a plus charge and a minus charge are going to have an attractive force. So we know that between these two charges here, there's an attractive force towards Q3. So I'm going to label that F1. And then I'll draw F or Q3 again separately. Because this is another plus and minus, this is another attractive force going this way. So this is F2. So since this is a vector quantity, we can add these two by doing tip to tail. So I'm going to take our F1, add F2, and this is just an estimate. And so I should get something that looks like this for F total. And so that's what we're looking for. So look at this, we want something that's going this direction down. So when we get our answer at the end, we want to check that that's what we get. So when we look to find our F total, we know that because it's pointing to the left and down, we're looking for two components. So if you remember from 2a, every vector quantity has an x component and a y component. So we need to find those two first before we find our F total. So the way we're going to do that, because we have two vectors that are adding to create F total, we need to find our x and y components for those two vectors separately. So I'm going to call one fx1 and fy1. And we also want fx2 and fy2. So when we're looking for fx1, we know we're using this formula to start out with. So we have k, q1, and q2. But when we look at the distance, we only want the distance in terms of the x direction. So I'm going to write Rx 1 to 3 squared. So we're looking at basically this little area. For Fy1, we have K, Q1, Q3. This should be Q3. And now we're looking at the distance in the y direction only. So I'm going to write Ry 1 to 3 squared. And we're going to do the same thing for the second charge. Okay, so then when we're ready, we're not going to plug in any numbers for this problem. But when we want to find our total fx and our total fy, we just want to add the two x components and add the two y components. So our fx should be fx1, which we'll calculate using this formula, plus fy1, or sorry, x2, and then fy. So fy1 plus fy2. And now that we have our x component and our y component, the easiest thing to do is construct a triangle and just use Pythagorean's theorem. So if you remember Pythagorean's, it's just a squared plus b squared equals c squared, where this is the hypotenuse. So in this case, this is our f total. So our a squared is our fx component, and our y squared or b squared is going to be our fy. You could choose either one. So I'm just going to write fx squared plus fy squared, which we'll calculate using this, equals f total squared. So to solve for your f total, you just need to take the square root. So once you have this, you're basically just going to plug into this what we had for xy, what we have for fy, and then your x1, we have this, x2, we have this, and you're just plugging everything in. And the best way to do that is to write everything out in terms of variables first, do the algebra, and then only at the end, once you've finished writing out everything, is to then plug in the numbers. So that's how you do that.